Welcome to the Enterprise Excellence Podcast, where our purpose is to help create a better future. Learn from our world's experts how to improve your organisation sustainably. Learn how to achieve and sustain an excellence journey for yourself, others, and the planet.
And I'm your host, Brad Jevons, coming to you from Brisbane, Australia. We are proudly brought to you in association with SA Partners, a world-leading business transformation consultancy. SA Partners are a truly purposeful company focused on helping organisations achieve sustainable improvement for themselves, others, and the planet. Welcome to episode 113 of the Enterprise Excellence Podcast. It is such a pleasure to have Mr Michel Baudin on the show with us today. Michel has been researching, practising, writing, and consulting in the fields of operational excellence since the 1970s. He has helped organisations all over the world. Michel is a lecturer at the UC Berkley, University of Dayton, the Hong Kong Productivity Council, and University of Buckingham. He has written 4 books: Manufacturing Systems Analysis, Lean Assembly, Lean Logistics, and Working with Machines. His new book, together with Torbjorn Netland, is Introduction to Manufacturing, an industrial engineering and management perspective. We'll explore this further today. Let's get into the episode. Michel, thank you so much for joining us today.
Well, you're welcome. Just a couple of points. I'm not that old. I didn't start until the 1980s. And it's University of Dayton, not Daytona.
Dayton.
In Ohio, not Florida.
Yeah, nice. Well, it's certainly an impressive background, Michel. And I think you and I were talking before the show. You know, I've known of you since I first got involved in continuous improvement. You know, so amazing volume of knowledge and sharing you've had over the years. But Michel, what is your backstory? Like, what in your life led you down this path of being a researcher, writer, and sharer of knowledge in this space of excellence for so many years?
Well, I grew up in France and thinking that I want to be a writer when I grow up, and I still think that. But to be a writer, you have to have a life, and so I studied and became an engineer, and I wanted to do something useful, so I decided to work on earthquake prediction.
Wow.
And so when I got my degree in engineering, I went over to Japan to work in seismology on a Japanese government grant. And I wasn't very good at it. I don't think anybody is. Nobody's succeeded in predicting earthquakes since then. But in a couple of years later, I was drafted and sent to the French embassy in Japan to work in the scientific service. And as part of my job in the scientific service was organizing factory visits for delegations from France. And that was a revelation to me. Learning visiting factories from Toyota, Sumitomo, Hitachi, and a large number of others, Nissan, and it was a revelation to me because I suddenly realized that this was a field where it was much more realistic to do something useful than in earthquake prediction, and so. That was my initiation to it, and I decided to go work in that. And so I took a job after my national service in the semiconductor industry, and it took me to Silicon Valley for a period of 6 months, which extended to 41 years. And I started working as a process engineer in the semiconductor industry and stayed at it for a while, and then moved on to developing MES software for the semiconductor industry. And that took me back to Japan a few years later, where I managed to meet a Japanese consultant named Kei Abe, who at the time I was working on my first book, which was based on my experience in developing production planning and scheduling software. And I needed somebody to read what I wrote and give me some feedback about it. And he wasn't interested in doing that, which he said very clearly, but he was very interested in having a new partner. And so he offered me to come and work with him. So after some hesitation, I did join him. That got me started in the manufacturing consulting business back in 1987. And so with him, I traveled to a lot of different countries as for sort of apprentice to Keabe. And we went to work in very different industries. Some of the car industry, mostly in Argentina, which was very interesting experience because it's small. So you get to see every aspect of the industry, which you don't when you get involved with that industry and where it's more developed. But also detergent powders, frozen foods, industrial ceramics, very, very broad variety of fields. And I worked with him for about 8 years. And I was better at writing and putting together slides than my Japanese colleagues, and so that fell to me to produce a lot of the material we use for training our clients and writing reports to clients as well. And so I ended up writing a lot of the material that later fed into my books. And so after about 8 years of this, I set out on my own and started not being somebody else's apprentice, but having to come up with answer all the clients' questions myself, which was a change. And so I started working with companies like Boeing, Honda of America, Raytheon, etc., on my own at that time, and then with other colleagues that who joined me in our little group. It always remained a small group. It never had the ambition of building a 50-member firm, or because that just wasn't the philosophy. And so by about 2002, my first book came out in 1990, and then the second book came out 12 years later. And my reason for writing it is that I felt the field of assembly was one that was undercovered in the literature. You could find a few books about car assembly and a few books that were essentially mathematical models, but nothing practical on how you would assemble for example, surgery robot. And so I put together what I had learned from a lot of projects in the field into this book called Lean Assembly, which came out in 2002 with Productivity Press. And that was it really filled a niche, and it still filled that niche, and that book is still around. And I mentioned the example of surgery robots because one company I've been following, which is actually very near here, is Intuitive Surgical. And I went to visit Intuitive Surgical as part of an SME Society of Manufacturing Engineers event in Santa Clara, and then a few months later, I went there again to visit it on my own, and some of the things they did on the floor looked awfully familiar. And the engineer was showing me around. Well, yeah, we've been using this book. It was mine. So this is not really a client because I never collected a dime in fees from them, but it's probably the most thorough example of applications of what I put in this book, which was quite gratifying to see.
That's amazing. The career you've had, Michel, is awesome. And I've got a question that's burning in my mind on this. You have been involved in this journey from early on, and you've been across some amazing companies. And I'm sure you've had wins, and I'm sure you've seen failures where it just hasn't stuck or gone well. Mm-hmm. Michel, what do you see as the key ingredient of this going well? The knowledge coming out of Japan, or let's just say best practices, knowledge coming out of best practice manufacturing.
what defines it actually going well in a company like that, robotics company, or it not going well and falling over? What do you say is the key ingredients there?
Well, I mean, this robotics company went from being a startup with when I first visited, they made $50 million a year in sales. When I last visited them, they made $2 billion. So it was a success. I don't claim credit for this. I mean, they made the Da Vinci robots are extraordinary machines, and so their design, their product deserves a lot of credit for it. But it was clearly, I clearly consider it a success. Why is the sort of thing I've been doing not generally used? In a lot of companies, the top management is just not that interested. They're just so. You see a lot of people are writing about how top management is doing a miserable job and is responsible for the failure of X or Y or Z. Okay, I don't really see it as my problem. If a company needs my help and I can provide it, I can make them successful, that's great. But if I can't single-handedly turn around the entire American industry, that's too bad. It's not my. I don't want to make it my problem. Let's put it that way. What really matters to me is if I'm asked to do something and help a company do something, can I actually do it? That's. And so, does it require top management to be to actually lead the effort? Generally, yes. I mean, if the CEO wants something to happen, it tends to happen. Is it possible for people who are at middling levels or who are engineers or low-level managers to do things that are spectacularly successful in work? It's rare, but it happens. Then of two things: one, either management realizes what they have in these people and they thrive in the company and they bring the management along, or they leave. And the latter is unfortunately the most common.
Yeah.
But you do encounter this kind of people. Some of my consulting colleagues are actually people who started out doing some work internally, but they weren't at a level in the company where they could transform the entire company. There is the one thing that I find somewhat frustrating in all the discussions that I see online and a lot of the literature is that it doesn't get to the technical or even the managerial issues that are really fundamental. For example, you see a lot of talk about what it is to be a great leader.
Heaps.
But, pardon me?
Heaps. There's a lot that just hones on leadership. Yeah.
Yes. Okay. But there's a bit of a problem is that you don't see a lot written about human resource management. Yeah. What are the policies of the company with respect to human resources? Do they hire people because they need a hot body to a warm body to do this particular job, or do they recruit people for entire careers? Yeah. And if they hire people for entire career, it has a whole slew of consequences that are embedded in the human resource policies. First of all, they have to be very careful about who they hire. That's clear. But then people that are hired become employees, then you have to help them plan a career inside the company and give them perspective so that if they enter at age 25, they can retire at age 65 from that company and having done a variety of useful things for the company that match their level of expertise, and the company has developed that expertise, and that all that sort of thing doesn't get a lot of discussion. Right? You don't see a lot threads on LinkedIn or in any of the social media about human resource policies at Toyota, for example.
Mm-hmm. Yeah.
And I've had the I don't know if you've had Tracy Richards on your podcast.
Not as yet.
She's written a book called the Toyota Engagement Equations, and I've had one-on-one conversation with her about what about the HR policies, and she said that no, she knows what they are, of course, but she's not comfortable discussing them.
Yeah.
Well, unfortunately, we need to discuss them because they're really essential.
Yeah. Well, I remember, Michel, back in university, I studied Japan, and so much of that study was based on lifetime employment back then, that I was doing at QUT, and the infrastructures and the employee journey approach that Japanese companies, it wasn't just Toyota, took to enable lifetime employment. Like the bulk of the course that I did was on that. And I got to admit, when I was at uni, I understood it. It's only now. It's right now. You look at what the world's going through right now, a lot of the world with employment, it's like those philosophies, if you've been tuning that gear on how do you give employees a journey for employment as long as possible and keep developing their capability, boy, those companies are loving it right now, more than the ones that haven't had that focus since day dot.
Well, I did when I was doing the software work in the late 80s. I did sell software to Hitachi, and this was production control software, and I got along real well with my counterpart at Hitachi, and we had a lot of conversation. And this guy had spent 5 years as a design engineer in the company. So you had somebody in production control who was in a position to choose software to run production control in the company, who had a background in designing the product. Okay. Why? Because there was this policy that there was this for people who high potential people within the company would be rotated between these different departments to give them exposure to various parts of the company, which is essentially grooming them for top management positions.
Yeah.
And some companies in the US have that, but it's not necessarily done. It's not enough to have that in place. In some companies, the way you go through these rotations, but the way you get ahead through these rotations by not making waves.
Yeah. Yeah.
And that's actually not the idea.
No, well, you don't have performance ND. You've got basically mediocre in politics.
But you have companies that are not Japanese that have done a great job of this. Remember when one of the companies we worked with when I was with Keabe was Unilever, and we went to Italy in this plant that made frozen foods in Italy. Okay. And we saw on our third or fourth visit there was a young guy there who was a German engineer who had been put as first line manager on a production line in Italy. He arrived there not speaking Italian, and within about 5 months he was fluent in Italian, and he got along real well with the workers on the line in that plant. That was a case where this was not a Japanese company, the Dutch British company, and they were doing this sincerely. So this guy wasn't just. It wasn't something he needed to punch on his resume. He was putting his whole heart into it.
Yeah, I was just chatting to someone yesterday about McDonald's and whether everyone's got their different view, but I know that they're an organization that is really tuned on bringing people in and then bringing them up through the organization. I remember studying McDonaldization back in the day, but yeah, I guess there's an element of that there, isn't there? That bring
I'm
people
familiar
in.
with McDonald's.
Yeah, it's same type of, well, let's not say same, but there's that more lifetime employment, bring people up through the ranks and up into the organization and keep that longer journey going. Like that's really insightful for me, is that what you're saying is that whole employee journey and that focus on the employee factor is so critical. And I can see for the fact of sustainability of an excellence journey too, because there's no faster way to destroy any sort of journey than have a number of leaders change and bring people in from external who just don't believe in what's going on, and they completely change things, and boom, everything that's been done is gone. So that employee journey that succeeds people and brings them through and cross trains and gets that broader knowledge and grows them. There's a real logic in that.
And the stability is also very important, because one of the showcase companies of lean in the U.S. was Wire Mold. And the electrical products in New Hampshire, they brought in this guy Art Byrne to run the company in the early 90s, and he came from Danaher, and he has a strong background in lean manufacturing. He changed the company completely. It was a great success story. They started buying out all sorts of competitors, grew like crazy. And then in 2000, I think it's 2001, they sold the company to a much larger company called Legrand. It's a French company. And then Legrand proceeded to undo everything that Art Byrne had done. Art Byrne and his team had done. And so it's a lot of the former Wire Mold employees, engineers, executives have become consultants. They keep talking about their experience at Wire Mold, but unfortunately, the place where it happened has fallen out completely.
Yeah, there's so many stories like that, Michel, isn't there?
Yeah.
And Michel, and what I'm keen to know too, Michel, is yourself and Torbjorn, you've written this book, Manufacturing Management Now, which links a lot to what we're talking about, but is an extremely important factor. What was it that inspired you both to write this book now?
You mean Introduction to Manufacturing?
Yeah.
Well, I wrote my previous books from lean assembly, lean logistics, and working with machines for manufacturing professionals. So the lean assembly was for people who were putting together or running assembly lines. Lean logistics for the people who do all the support activities to bring materials to production and send products out from production. Working with machines for people who were working on designing or operating production lines that involve interactions between people and machines as opposed to manual work. But every time it was addressed to an audience of people who were doing this work in factories. And one of the things I've wanted to do for a long time is to write for university students. So students of industrial engineering primarily. I even sat on the external advisory board of an IE program at the university in Ohio, at Ohio University, and so I got exposed to how that was being done, and I felt the need to essentially provide people who are studying in this field with the tools that they will find useful 20 years down the road when working in manufacturing. Okay? And since I'm not an academic, I don't know how to write a textbook for students. So I had to find a partner in academia who was willing to work with me on putting together a book that would contain all the material that I thought should be in there, but could serve as a textbook for university students. And so, and Torbjorn Netland, whom I knew, I got to know him through online exchanges, and we got along well that way. And I told him about it. And he agreed to do it, and that was the rest is history. That was 5 years ago. We started working on this, and there were a lot of things I really had no idea of. For example, when you talk to university students, you have to explain what manufacturing is.
Oh yeah.
You have to talk to people who are active in a factory and have been working there for 5 years or 10 years or 15. You don't need to explain that, right? But for students, you do. And on the other hand, if you start talking about abstract models of production to people who are practitioners in the field, their eyes glaze over very quickly.
Yeah.
If you don't discuss that with students, they think there's something missing. Yeah. So it's kind of a different focus. Okay, and there's all the review questions and stop and think and boxes and all sorts of stuff that are part and parcel of a textbook that is just had no idea how to write. So it was a really good partnership with Torbjorn, because he's very good at that sort of thing. So.
That's awesome. And it's great to hear that background from, having to write differently for a university. Like I've written a book, but just in general, never even thought about the complexity of writing a university textbook in that regard. What were the key areas of knowledge that you're getting across to students or anyone who can buy this book in the future? What were those key areas that you were both honing in on with the book?
Well, one of the one key point for me is that you have to connect management and technology. You can't. You have technical books by engineers that contain models of production line. You have management books about how to run a manufacturing organization, but you really should consider the two jointly, not separately, because there is an interplay between the two. Right? You can't put together a manufacturing cell without thinking through how are people going to be working in it.
Mm.
So how you organize a team to run a manufacturing cell. That's management. Okay. And we found that there are books about management, there are books about technology, but we needed to have one that connected the two. Okay. And that's what we've tried to do.
Yeah. Go to the enterpriseexcellencepodcast.com/downloads to get hold of an employee journey mapping template we use to help organizations consider and improve this critical element of any organization. Please like, subscribe, and share this podcast to help others gain insights and create a better future. Let's get back to the episode. Yeah. Educate on how to bring people and technology together to create great outcomes in a factory. What are the key aspects there that need to be considered, Michel? What would you say are the key factors that when you're looking to manage a factory and connect people and technology, what are the key aspects that people should consider?
Well, for example, you place a factory in a particular social, cultural environment. Right? You install a factory in Nigeria, you put it in Portugal, you put it in Germany, and the people will come from that area to work in the plant. Fundamentally, there is no technically there is no there's nothing that will work in one place that will not work in another one. But you may have to package it differently in order to make it accessible or acceptable to the people who actually do the work, and the way you go about it may also be economically different. Now, one example, for example, in when Toyota came out about something like 15 years ago with its global body line. That's the to my knowledge, the latest version of their body welding assembly for cars. They designed it so that you could have robots do the welding work in some factories, and you could have people do the manual welding in others.
Yeah.
So otherwise, using the same fixtures, using the same. So that was the constraint that they went by. And why is that? Because if they put an assembly plant in Western Europe, and if they put one in the Philippines, the volumes of production, the availability of the equipment, the availability of the knowledge to maintain this equipment are going to be different. They're going to have different costs. So the economics of using the technology you're using are going to be different in different places. Okay.
Yeah.
So, if you do what they did, and so you install in one country a plant where all this work is going to be done manually, and that works well, and the plant grows, and sales grow, and volumes grow, and the skills of the people that get increase over time. There's nothing preventing you from automating this work because it's been designed to be able to work either way, right? So it's takes into account the possible evolution.
Mm-hmm. Yeah.
So yeah. Of course, it was technically quite difficult for them to do this. I inquired about it at the time. They had some challenges with developing fixtures that would hold the body parts from the inside, so that people could work from the outside to weld them, and things like that. The precision had to be higher than otherwise. But anyway, that what impressed me was the concept as an example of considering management and technology together. The HR policies I mentioned are the same issue. So if you hire people for a career, and they know that they're in the company for the long haul, okay? They will be willing to do things that they otherwise won't be willing to, like work on improving the processes. Okay? And if they work on improving the processes, their skills improve and they become better at it. And it's a whole dynamic, a human and technical dynamic that gets started. So that's where these things happen.
Yeah, nice.
Another thing we did on this textbook that hadn't done as much in the previous books is focus on the information technology and operations technology, IT and OT aspect of it. That is also something that much of the material we had to develop from scratch for this.
Yeah, that's neat. So Michel, you got that concept in there of considering a country's culture, but also that global perspective of difference when it comes to manufacturing management and planning for that. The whole piece of that we spoke about, which is that employee journey, and how do you bring that into play to create that longer term thinking and, drive that continuous improvement and engagement piece, which is HR.
I want to be careful about the national culture issue, because fundamentally it's never a block. There's no case where the national culture prevents you from being excellent in manufacturing, and you have a lot of people who pretend that it is.
Mm.
And I don't like to bring up national culture, because it's always used as a disabler. No, we can't do SMED because the people who work here are from country X.
Yeah.
And it's just not true. I mean, you can use that everywhere. The more technical it is, the more universal it is.
Mm.
But there are some nuances, and so in the way you package things, and the way you present them, and the way you recognize people. Like for example, it's a detail, but Americans are very fond of plaques. Right, you give them an engraved plaque, Employee of the Month. Okay, so they proudly put that in their cubicles, or they proudly post that. You try that with the French, and they get upset.
Mm.
They'll throw these things in the garbage because they think it's ridiculous. They think they're being manipulated. Okay. So you have to find something else. Right? And what for example, what works in that context is to have some work that was done in the factory written up in the local newspaper.
Got you.
So you have to, it's on those kind of detail that you have to think through about cultural differences, not on the essential.
Yeah.
But these details matter. If you neglect them, you can upset people for no good reason.
Mm. Or if you try cookie cut one approach across the whole world, you're going to make some happy and annoy a lot of others.
Well, I mean, there are all sorts of issues. There are cases where, for example, the CEO goes to Japan, CEO of a medium-sized company, owner operator of that company, maybe 1,000 employees, one factory. He goes over to Japan and sees factory, and he sees one factory where they're using golf balls as kanbans with a pneumatic system. He says, "Oh, that's neat." He brings it. He goes home and says, "We want to use that in our factory," and it's a total failure.
Yeah.
And why is it a total failure? The only reason it's total failure in this case is because it comes from the boss.
Mm.
Maybe it could technically have worked, but the fact that it was the CEO who brought this in from Japan and pushed it on everybody else made them reject it. Maybe it was a bad idea, maybe it was a good idea, we'll never know. But the way it was presented, the way it was introduced, made it impossible to function.
So there you've got a culture that doesn't accept huge power distance or something like that. And so when the boss comes and tries to shove down a system or a tool into the business, they rebuck it.
I think it's well, I don't know if it happens everywhere. I tend to think it does. It's no, when you're the boss and you emit an opinion on a technical matter, people will react in one of two ways. They'll agree to everything you say because you're the boss, or they'll make a point of opposing everything you say because you're the boss.
Yeah.
So you have to be very careful about this, and it means essentially, even if you have a background in engineering and it's an engineering issue, you just shut up and let the more junior people figure it out.
Yeah, yeah. Engage them and involve them. How have you seen that on the flip side, Michel, where that's been done well, where a leader might have seen something in Japan and then gone about an approach that actually helps get success and helps the organization move forward based on their learning?
Well, factory visits are very useful, but whether it's in Japan or elsewhere, but you have to be careful about when you organize them and who you take on these tours. One of the things, for example, that one of the very useful concepts when you organize a team to go on factory tours is to take people from several levels of the organization. So you bring in a division general manager, a production manager, a first line manager in production, a maintenance technician, and a couple operators. And the fact that you get this vertical slice of the organization means that when you visit a company, these people will ask questions at different levels for different. They will gather different kinds of information. Mm-hmm. And so the information you get as a result of that is richer than if you send a homogeneous group, like all the division general managers, for example. It's better if you take a vertical slice. The other thing is, if you take people who are beginners in improvement, it's people who have never done an improvement project in their life. Kaizen is new to them. They maybe had a class on it, and off they go to visit the factory. They're just not going to see anything. They're going to come back saying, "Well, these guys are no different from us. No, we're doing just as well." If, on the other hand, you take people who have a few projects under their belts before they go on a factory tour, their eyes light up and they see all sorts of things that the other ones don't see. So these factory tours are very useful, but don't take beginners on these tours. Take people who have done some improvement work before, and then you get a lot of value out of it.
Yeah, and consider a vertical slice of representatives to go with you and learn.
Well, those are two items that come to mind. Come to mind immediately.
Thanks, I really appreciate it. But with one question I've got with your area of IT and OT, so bringing information technology and operations technology together, what do you see as pivotal to? Because I've seen a lot of failure there where the two don't meet. It's a mess. What would you say is key to success with bring information technology and operations technology together?
It's a difficult question, but I think let's start with what doesn't work. Let's say somebody sells an ERP package to top management, okay, and that's adopted. A lot of money is being spent in actually populating databases, etc. And when it comes down to from the top, when it tries to percolate down to where the work is actually being done, there's a big disconnect. That is, there's output from that system, and that output is published, and people see it on the floor, but they can't do what this output says.
Yeah,
because there are mistakes in the database. I mean, for all sorts of reasons, everybody I think has experienced that. And that's organized by an IT department whose members very frequently don't have much of an understanding of manufacturing. They see manufacturing through the lenses of an ERP model that is unrealistic.
Yeah.
Has been unrealistic for 60 years and is still unrealistic. Okay. So on the other side, you have people on the shop floor who do things with control systems of machines. They implement SCADA systems. They work with PLCs. They work with CNCs. They work with the machine controller that are neither PLCs nor CNCs for more advanced machines, and they actually they're at the juncture they're actually operating on machines that touch the material, that actually do something to the material. Okay, and what they do works. It has to, right? And when you start building up on that, you can get to higher level functions, like SCADA functions are higher level than just direct control functions. And then you can have some analytics added to that, local analytics that actually works. And then you have the problem is you have this layer of OT that works, and then you have the IT layer and no connection between the two. And how do you make a connection between the two? I think the key here is the information model. It's not the technology. It's not which kind of database you put it in. It's your product nomenclature, your equipment nomenclature, the relationships, how you think about your bills of materials, all these kind of conceptual details of how you organize your information, regardless of technology. It's about the content. Okay? If you work this out, then you can have a structure that will work with OT and work with IT. So that's one consideration. Another one is also to figure out, have an idea of what information has to be known to everybody and which one doesn't. I mean, the most obvious level is you put sensors on the machine that collect 100 readings a second, and you don't need 100 readings a second. Yeah. For temperature. If you get one a minute, that's enough. Okay, so you don't want to pass up information that will just crowd the system for no purpose. Okay, so but there is also all sorts of details about the operations that really don't need to go beyond the operation itself. How do the control programs work on the machine's controller? Okay, that can be managed locally to a degree, because you have another issue that you need to address is if you have 180 factories throughout the world, and this particular operation is done in 30 of them, you want that operation to be done the same way in all 30 factories. Yeah. And the more control you devolve to the local unit, the more difficult it is to make sure that they're all on the same page. Yeah. Yeah. If you standardize the way it's done, then you tell people then you can't improve on it. Yeah. So you want to that's a technical challenge. You want the local people to be able to improve on the processes, and then when they come up with an improvement, propagate it to everybody else who can benefit from it. Again, it's doable, but it requires a lot of effort and a lot of attention.
Yeah, there's that that real pressure of what to standardize and what to control, and what not to, what to allow more freedom and flexibility across the globe.
Well, I mean, the sort of thing that you don't want to. I mean, there was an anecdote that about standardization that I heard from Kei Abe. He used to work at Honda in the days of Soichiro Honda, and one of the things that Soichiro Honda found out is that there was a standard in Germany, a DIN standard, for the size of the steel balls at the end of motorcycle brake handles. And the existence of this standard led Soichiro Honda to conclude that the German motorcycle industry was doomed.
Yeah.
Because you don't need to standardize this. It's just so you want to make sure that you standardize what needs to be, and you don't what doesn't need to be.
Yeah.
It's probably a good idea to have provide work clothes to shop floor operators, but the uniforms don't have to be the same in different countries. What's important, for example, is to have no clear markings of rank in the way people dress.
Mm.
Yeah. So it's very common in Germany that you have a different color of overalls for people at different hierarchical levels. Right?
Oh wow, yeah.
But you go to a Japanese plant, and the plant manager wears the same overall as the shop floor operators.
Yeah, wow.
They don't wear a suit and tie when they go on the floor, right?
Mm.
It's not unimportant, but those are the sort of things you don't. There, for example, you may want to standardize the fact that you dress, if you're a manager, you dress the same way the operators do. That's one rule. What that way is doesn't necessarily have to be standardized.
Yeah, yeah. So it's
if you try to make a Boeing machinists wear a uniform, they probably wouldn't agree.
Mm.
But there are companies where that's not a problem.
Yeah. So standardize what needs to be standardized to deliver a great culture and great outcomes, but provide the flexibility where the flexibility is needed that allows for improvement and, I guess, ownership and empowerment across the globe.
Don't standardize anything you don't need to.
Yeah, too true. Michel, with this area of expertise and the new book, Introduction to Manufacturing Management, what would be your...
just introduction to manufacturing.
Oh, introduction to manufacturing. Sorry about that. With introduction to manufacturing, what would be your 2-minute tip with that book and that area that you're writing about now? What would you give listeners as that key 2-minute tip?
It's a book that's intended for people who will be working in manufacturing as engineers or managers, and it's intended to help them for a long period of time. So we try to stay away from what is currently fashionable and come up with something that is likely to be useful to them in the long run. And so it is a lot of people have expressed interest in this book who are not students. A lot of professionals say, I want to have they've written to me, say, I'd like to have a copy of this book. That's wonderful. It's meant for students, but if it's usable by professionals who are not students, that's wonderful too. But our target audience is students.
Yeah, neat. And it's great that you've written this in a way that, you know, these younger people coming through to start their career in manufacturing are going to be able to learn from such a base of knowledge. It's brilliant. Michel, what's been something that you've learned recently that you didn't know before? What's been a recent insight for you?
That's a good question. I've spent a lot of time on data science for manufacturing recently, and it's a huge subject, and there's not a lot. Again, it's one where there's a lot written about data science. There's not a lot written about data science for manufacturing. So I've learned techniques, I've learned algorithm. I don't want to go into the details of them, but I look at this and say, can we use this? What can we use this for? Is there and I find that a lot of times very old-fashioned thinking is still prevalent. One of the odd things I encountered, this is, you're saying something recent, it's about a couple of years old, but if you look at the literature, the standard literature on operations research, you don't find the name of Vassoni in the index. He seems to have vanished. And it turns out that this person, Andrew Vassoni, in the 1950s, came up with a whole theory of bills of materials and algorithms to manipulate bills of materials that are actually quite useful to know if you're going to do some engineering work about an assembled product.
Wow.
And so that's one nugget that I've encountered fairly recently that I'm trying. I've shared some of that on the blog. I don't know if you've seen the BOM wrap, BOM wrap series of posts. I cover that fairly extensively. It's something I discovered fairly recently.
It's amazing the study. It's amazing the study and research of many people through the past can apply so well with what's happening now. Yeah. Michel, going forward, how can people get hold of the book and how can they reach out to you if they want to connect to learn more?
Well, they can reach me by email. They can reach me by LinkedIn. They can reach me by my blog. My blog is michelbaudin.com. I suppose you're going to post a slide with that.
We'll share that.
My email is michel.baudin@tactimes.com, and I'm on LinkedIn as Michel Baudin. So I'm not hard to find.
Yeah. Well, Michel, thank you so much for everything you have done with books and knowledge and sharing and helping organizations around the world and everything you continue to do into the future. Thanks so much for helping us create a better future.
One of the things coming up in September is that we're going to have a second edition of the Van Full of Nerds tour that Christoph Roser had organized in Germany in 2019. We were supposed to do it in 2020, the second edition, but because of COVID, it's going to be this year. And it's going to be, Christoph Roser organized it in Germany to look at the flagship Industry 4.0 companies in Germany. This time we're doing it in France, and maybe we're going to do it in the US in a year or so. But it's an upcoming event.
That sounds awesome, especially being able to look at, I guess it hones on that topic of the digital path and where we're going, isn't it? So it's perfect.
I know one thing that struck me, there are several things that struck me in 2019. One was just how much there was to pick-to-light systems, and how they're not mentioned as important an important part of Industry 4.0, but in terms of semi-automation of assembly work, they're really very useful and very promising. Another thing that struck me when we visited these plants in Germany is how the PLC, the programmable logic controller, that's really a 50-year-old design, is really the workhorse of automation in manufacturing today. It's not robots. People talk about robots all the time, but robots are a few 100,000 a year, whereas PLCs are made at the rate of something like 50 million a year. So it's kind of a different scale. So
Yeah.
those are some of the takeaways I had in 2019, and I look forward to what we're going to see in 2022.
Yeah, Michelle, the amount of Siemens or Allen Bradley PLCs around the world and other brands is massive.
It's massive, yes, and it's really a somewhat of a clunky type of concept. It's just you'd think if you were designing from scratch today a general machine to control production facility, you wouldn't do a PLC, right? The PLC was designed to accommodate. I found out it was in the late 1960s at GM. There were a number of people who were used to relay panels, and the idea of the PLC was to minimize the shift for them to from what they were used to the new one. And then 60 years later, we're stuck with design choices that were made to accommodate these people in this particular factory, and it's multiplied by the millions of tens of millions made every year.
Oh, it's massive. I remember when I was first introduced to them, it was, what is it? It's a computer without a screen. Okay, I get that.
Did you learn ladder logic?
No, but I was involved in just basically programming into certain PLCs machine language to just drive certain outcomes. Basically, the code to push out once certain, circuits are closed and opened. That's as far as I went. But organizations I led were heavily involved in that, but I did know how to do basic stuff myself.
When I looked at when we went to a university in Germany, and what they were teaching students in robotics was how to have PLCs talk to SAP.
Yeah.
And when you look at a robotics lab at a UC in California, students are using Raspberry Pis and Arduino controllers. So it's completely different kind of situation.
Yeah, and now you've got cloud-based solutions for controlling factories, like cloud-based MES, and that's becoming very prominent. And so it's execution, I should say. So it's all evolving so fast, but it's amazing for the future. Well, Michel, thank you so much for your time, and thanks for everything you do. And we'll look forward to catching you with the next book or another episode in the future. What a great episode. Remember, you can visit our website, enterpriseexcellencepodcast.com/downloads, to get hold of an employee journey mapping template we use to help organizations consider and improve this critical element of any organization. Please like, subscribe, and share this podcast to help others gain insights and create a better future. There were 2 key takeaways for me from this episode. Firstly, how vital the employee journey is to achieving excellence within an organization. Achieving and sustaining an excellence journey depends on people. The more an organization can create an employee journey that creates growth and tenure for their team member and considers succession planning to ensure the continuation of an excellence journey, the better the chances of success. Remembering the conversation Michel had about wire mold and what can happen there with dramatic changes in leadership and personnel is quite humbling. It's important that all organizations consider this. The second key takeaway for me was standardization. Standardize what needs to be standardized and provide flexibility with the rest. This was a great conversation with Michel about standardizing what needs to actually be standardized and providing the openness for localized continuous improvement with the rest. This topic applies to our discussion on connecting information technology and operational technology, and also process and machinery, and that whole standardization piece across globes or even within an organization locally. If we standardize too much in an organization, we create bureaucracy and disable improvement. If we don't standardize enough, we create chaos and destroy agility. Thanks again for your time and knowledge, Michel. Thanks for helping us create a better future. Bye for now.